All right, so this is the worksheet we're going to be looking at today. We're going to kind of explore how water pressure changes as we go deeper and deeper into the ocean. So the relationship between water pressure and ocean depth. All right, so at the surface, remember we are at 0 meters. All right, so as we increase in depth, and this little bit of information at the top does say it, for every 10 meters, we're going to increase 1 atmosphere of pressure. All right, so for this particular worksheet, we are working in atmospheres. So I'm gonna write it up here. For every 10 meters that we increase in depth, that equals a change in 1 atmospheric unit. All right, so right now you are sitting at 1 ATM anyway. So for every 10 meters that we go down the ocean, we have even more ATMs, all right? And 1 ATM is actually measured to be about 14.7 pounds per square inch. We are not using pounds per square inch on this particular worksheet, so we're just focusing on the 10 meters equals 1 ATM. All right, so for the first one, if we increase our depth by 30, we are going to increase our atmospheric units by 1 for each of those 10 meters. So it tells us that at the surface, our ATM is 0. All right, so for 300 meters below sea level, we need to figure out what that is in ATM. So what we're gonna do is take that 300 meters, we're going to divide it by our 10 meters, and that's gonna give us our ATMs. All right, so I'm gonna zoom in on this so that you can see exactly what I'm talking about. All right, so at 300 meters, we divide it by 10 meters, and we are going to end up with 30 ATMs, 30 atmospheric units worth of pressure at 300 meters below sea level. All right, so let me do this one real quick, and this is pretty self-explanatory once again, and divide it by 10 meters, so you should get 60 ATM for 600 meters worth of depth. All right, so you're gonna continue to do that all the way down until you get to 6,000 meters below sea level. Notice that it actually shows you some animals that we can find at these levels as well, which is kind of cool. All right, so then once you've done that, you're going to scoot over to the other side, and you're going to look at questions 1 through 5. So it's gonna ask you how much greater is the pressure at 3,000 meters compared to 6,000. So you're gonna look over here, you're gonna figure out what you got for 3,000, figure out what you got for 6,000, and compare the two of those. All right, and then it's gonna ask you what would the water pressure be if you were only 100 meters below the surface. Well, you start at 300 here, so you're just gonna figure out if it showed you above 300 meters, what would you see in terms of ATMs at the 100 meter level. Make sure that you are always, always, always giving yourself a unit on these. So add in your ATMs for this, and once again, your ATM for 1,000. All right, so then it's gonna ask you some questions about, what must be true about animals. It's gonna ask you, normal air pressure is about 1 atmospheric unit. So how far could you actually dive below the surface of the ocean without feeling more pressure than you're normally used to? So once again, you're gonna tell me in meters how deep you can go. And then you are going to describe if you were to graph depth versus pressure. So if you were to take this worksheet and you were to put it on a graph, what depth, or with depth going along the horizontal axis, so along the x-axis, and pressure going along the y-axis, what would the shape of the graph look like and why? Okay, so think about that when you're thinking about, okay, so here's my graph, here is depth across the x, here is pressure along the side. So what is happening as you increase in depth? What's happening to your pressure? All right, so kind of draw out your line, think about what sketch that would look like, and then explain to me why it would be that way.